All right, so we're going to start talking about the analytical and graphical connections between f of x, f prime of x, and f double prime of x, so the second derivative. Are you guys familiar with the second derivative? You have dealt with that some? Okay. So we're going to start today probably just talking about the first derivative, and then tomorrow we'll probably move on to the second derivative. So let's begin by filling in the following charts and the relationships that exist between the graphs of the function and its first derivative. So we know if f prime of x, so the first derivative, if it is 0 or undefined at some x equal to a, what can we tell about the original? If the derivative is 0.
It's a relative maximum.
Yeah, we're going to have some potential max or min. Potential max or min. If we're undefined at some point x equals a, I'm not sure if you guys know this yet. Do we know what that's called? A critical point? Does that sound familiar?
Yeah.
Okay, so if you're undefined at some point x equals a, that's what's known as a critical point. If f prime of x, the derivative, is greater than 0, what do we know about the original?
Positive slope.
It's increasing. If the derivative is less than 0, what do we know? Decreasing. What if we have a derivative that changes from positive to negative? Dan?
You'd have a maximum.
Yeah, it's going from positive, and then it's going back down to negative, so you would have a maximum. Has a maximum. Changes from negative to positive. Sorry, yeah, has a minimum. Has a minimum. All right, so moving right along, you've already seen this in action with polynomial functions. For the polynomial function below, determine the intervals where the graph is increasing, decreasing, has a relative max, and or has a relative minimum. Show your analysis and justify your answers. So we're going to go through this and show our answers, but then once we get our answers, we can actually look at our calculator to make sure our answers make sense. So how are we going to find our critical points? How do you think we're going to find our critical points? We know from up above a critical point was when this x was equal to a, but we found that after we've already done what? Yeah, so we're going to need to find a derivative. F prime of x. What is the derivative of x to the fourth? 4x cubed minus the derivative of 4x cubed. You get 12x squared, yep. To find your critical points, set that equal to 0. And we need to solve that. We can factor out 4x squared, which is x minus 3. And then we can have 4x squared equal to 0. So if we solve that, x would be equal to what? 0. X minus 3, if that's equal to 0, x would be 3. So those are our two critical points. And what we're actually going to do when we find these critical points, we are going to create a table with our intervals. So our function starts at negative infinity. And where does our first critical point happen? 0. Then we go from 0 to where? Where's our next critical point? 3. Then we start at 3 and go to where? Infinity. So this is actually going to be the basis for our table. If you want to, along the side, we're going to label f prime of x for the first one. And we'll leave that. So f prime of x. So within this interval from negative infinity to infinity, is f prime of x positive or negative? So pick a value within there. What's a value within this interval? We can pick -1. So we want to know whether f prime of x is positive or negative, so let's plug it into the derivative. -1 cubed is -1 times 4 is -4. -1 squared is just 1, so we're just at 12. -4 minus 12, is that going to give us a negative answer or positive? It's going to give us a negative answer, so we just want to know whether it's negative or positive. Check the next interval. Pick a number within that interval. See if your derivative is positive or negative. What is the value? Positive or negative value? It's a negative value again. And the last interval. Check whether a number within that interval, when you plug it into your derivative, whether it's positive or negative. Positive. Okay? So what does this tell us about our original function? Because this is all about the derivative here. What do we know about the original function? It's decreasing. So you can write decreasing, or you can put an arrow pointing down. You know that's decreasing. What's happening in this interval? It's decreasing. What's happening in our last interval? Increasing. Again, we're talking about our original. From the derivative, we're able to tell what is happening with the original. Now, I want to start with this one because it may be more obvious. Our derivative says we're going from a negative to a positive. So what is actually occurring right here? A little louder? A minimum, yeah. So right here between these two, we have a minimum. Do we know what value the minimum is actually at? 3. We know that minimum is going to be right at this value. This is where it's changing from negative to positive. Okay? What's happening here? Do we know what's happening right here? Go ahead.
F prime x order derivative is approaching 0, but it doesn't rise after 0, so it dips down to a plateau of sorts and then it goes back down.
Exactly. So we know we're still decreasing. So we're decreasing. We come to the x-axis, and we don't bounce off and go back up. We continue decreasing. So Dan's exactly right. We're going to come to some plateau. It's going to be level right here. Now let's actually think about this. Right here, we had a minimum. So that would be one of our multiplicity. But this here, multiplicity is going to be 3, and we need a multiplicity of 4, so it makes sense. Right here is a level, and right there is the minimum. Now what we can actually do, there are 4 things we need to tell from this. We can look at it in the graph first to make sure it makes sense. So if you want to go to your y equals, I'm going to ask for 4 more things, but let's look at the graph first. So once you type it in, go ahead and graph it. Now I have a window from yesterday, negative 10 to 10. You can use negative 5 to 5 if you'd like to, or negative 10 to 10. From what we found in our table, does this picture make sense? Do we have some kind of plateau where Dan said we would have a plateau? Yeah, right there at 0. And our critical point was at 0. So at x equals 0, we have some type of critical point. Our other critical point was at 3. So about 1, 2, 3, it said that we would have a what? What should we have at 3? A minimum. Now, it's off my graph. It's way off the bottom there. If we would expand our window, we would see it's going down to a what? It's going down to a minimum. So we verified our answer just by looking at the calculator, but our table here makes sense. All right. So now there's 4 things that I want to list here that could be true from what we found here. We know that f of x is increasing on what interval? What interval is f of x increasing? 3 to infinity. Because f prime of x is what? Yes. F prime of x is positive. F of x is decreasing on what interval? Yeah, negative infinity to 0, and we also have 0 to 3. I'm going to list both of them. Because f prime of x is what? Negative. So this is everything that we're able to tell just from the work we've done above. And next, we're basically listing out all the information you've told us. So f of x has a minimum at what x value? At x equals, yep. Because f prime of x, what? We know it's a minimum because f prime of x does what? Yep, changes negative to positive. Changes from negative to positive. One last thing. F of x does not have a max because f prime of x never does what? Does not have a max because f prime of x never does what? Stevie? Yeah, it never changes from positive. So it never changes from positive to negative. Any questions? All right, if no questions, turn over. Let's take a look at the back. All right, a polynomial functions deal with critical numbers where the first derivative is equal to 0. That's what we did on the front page. Since that initial investigation of these properties, we have talked about places where a function is not differentiable. In other words, places where the graph of a function has a cusp but does not exclude the existence of a relative max or min. Let's investigate such a case now. So analytically, find all intervals where f of x equals the x plus 2 to the 2/3 power plus 1 is increasing, decreasing, or has a relative max or min. After we do that, we'll sketch a graph to verify our results. All right, so we know that we're going to need to take the derivative, f prime of x, just like we did on the front side. So help me out. How do we get the derivative of this? Go ahead, Dan.
You have to utilize the chain rule. So
Okay.
you move the 2/3 down to the front, keep the middle to get 2/3 times x plus 2. You have to take the 2/3 in the top right and subtract 1 from that, so you get negative 1/3, and then you have to multiply that whole thing by the derivative of the inside, which would just be 1.
Which is
so
just
you can
1.
exclude that.
Exactly.
And the plus 1 gets plus 0, so you can exclude that as well.
Okay. So we're left with this, which we can rewrite as 2 over 3 and x plus 2 to the positive 1/3 power. You can move that to the bottom if you'd like. And what did we set that equal to on the front side to find critical points?
0.
We set it equal to 0. So in this one, the setup looks a little different. Is there some value that when equal to 0 here that's going to cause us trouble, or this function is going to cause trouble here? On the front, we were able to set it equal to 0, solve for our x values, and we had our critical points. This one's a little more challenging. Is there some kind of value, if we plug in for x, is going to cause us trouble? Or is this true for all values of x? Dan?
Negative 2.
Yeah, what happens if we plug in negative 2 here?
You get a 0 on the bottom, which is non-existent.
Yeah, we get a 0 on the bottom. We would get 0 not equal to 2. Well, that doesn't work. So at x equals 2, or negative 2, sorry, we have some type of critical point. Yes?
What do you mean by x doesn't equal 2? If you had the 0 on the bottom, then you can't divide by 0.
Yeah, sorry. You would get undefined here. So you'd have 0 equals some undefined.
Yeah.
But we know at that value, x equals negative 2, that's our critical point. We have
Yes.
something going on there. Okay. Well, now we need to make our table. I'll go ahead and write this down here. We're starting at negative infinity and going to where? Negative 2. That's our critical point. Then we go from negative 2 to where? Infinity. Okay. F prime of x here and f of x. In this interval, f prime of x, is it positive or negative? So go ahead, take a minute, figure out whether in this interval here, if f prime of x is negative or positive. So pick a number within the interval. Okay, so we get a negative value. So we know f prime of x at that point is negative. In this interval, if you plug in a value, is our derivative positive or negative? Positive. Okay. If the derivative is negative, what does that tell us about the original again?
Decreasing.
Decreasing. So you can write decreasing. I'm going to put an arrow down. I know that my original is decreasing. You can write decreasing or put a down arrow. If the derivative, is positive, the original is what? Increasing. So what is happening right here? Minimum. Yep. Right here we have a minimum. It's going from negative to positive. Now, let's actually take a look at that on the calculator before we write out the 4 things that we know about this. So go ahead and type the original into your calculator. And let's go ahead and we're going to sketch this on our graph that they provided there. So we know that our critical point was at -2. It looks like it's at -2 what?
1.
Looks like it's at -2, 1. And what's actually happening there? We have what?
Sharp.
A sharp point. It's coming down from one direction, stops there, and then it goes up the other direction. So I'm just going to roughly draw it in there. It looks something like that. So we verified with the calculator that we do have a min at that -2. But let's write out what we know. F of x is decreasing on the interval. Well, you told me it was the interval -infinity to -2 because f prime of x is negative. So we know f of x is decreasing because the derivative is negative at that point. We also know that f of x is increasing on the interval of -2 to infinity. This interval over here, it was positive because f prime of x is positive. Now, based on the problem from the front side, what do you think are the last 2 bullet points we're going to talk about? All right, so somebody tell me, what are we going to say about the max, or what are we going to say about the min?
F of x has a min at x equals -2 because f prime of x changes negative to positive.
Exactly. You need to write f of x has a minimum at x equals -2 because f prime of x changes from negative to positive. Because f prime of x changes from negative to positive. What do we know about this minimum? Okay, because it's a what? Okay, so we know the minimum's a sharp point. It is a sharp point. Because f prime of x is undefined. Undefined at x equals 2. negative 2, sorry. Undefined at x equals negative 2. And I'm going to erase the chart here so I have room to write the last thing. Okay, we just talked about the minimum. What do we know about the maximum? F of x what?
Has no maximum
Why?
because f prime of x never changes from positive to negative.
Exactly. F of x has no max because never changes from positive to negative. Anything that's too striking there or really confusing, or we're doing okay with those ideas? Critical points, positives, negatives, increasing and decreasing. All right, so we have a few statements at the bottom that could be important. So the first derivative of a function identifies intervals where a function is increasing, decreasing, or has a relative max or min. So that's what the first derivative tells you. We use that today. In similar fashion, the second derivative, so f prime prime of x, identifies intervals where a function is concave up, concave down, or has a point of inflection. A point of inflection is what? What is happening at a point of inflection? Do we remember what a point of inflection is? Not sure?
Isn't that when the concave is like changing from an up through down?
Exactly. Concavity changes. That's the point of inflection. So on a graph, if you were going, you're coming from a max, going down towards a min, and at that point where it changes from concave down to concave up, that would be your point of inflection. Your POI, point of inflection, between that max and min. Okay. Since the second derivative is the first derivative of the first derivative, f prime of x, then the same relationships that exist between f of x and f prime of x must exist between f prime of x and f prime prime of x. So it could be a little confusing, but what that means, so an example, if f prime of x is positive, you said that f of x is what? We use this today. If f prime of x is positive, what do we know about f of x? Increasing. Okay? But if f prime prime of x is positive, f prime of x is what? If we know that the second derivative is positive, what do we know about the first derivative? It's increasing. This is just telling us the relationship stays the same. We know that the first derivative tells us about the original. We know the second derivative tells us about the first derivative. All right. So that covers the first derivative with the critical points. Tomorrow we're going to move on, kind of doing the same thing but with the second derivative. So that covers what we're going to cover for today. All right, any questions? All right.
Do you want to